Here's the final multiple choice question from the AP Stats test preview through Bluebook. And this question says we've got an athletic trainer wanting to investigate the relationship between athletes' resting heart rates and heart rates after exercise. So they have 12 athletes and they record each athlete's resting heart rate measured in beats per minute. Then they measure their heart rate again, also measured in beats per minute after 5 minutes of moderate exercise. So the results of the regression analysis of the data are shown in the following computer output. We're going to assume all the conditions for inference are met. Which of the following represents a 95% confidence interval for the slope of the least square regression line? So the way that we build a confidence interval is we always take our statistics, so what we measure from our sample, it's called our point estimate, and then we go up and down from that point estimate by our margin of error. Our margin of error is a product of two things, our critical value and the standard error of our statistic. So we've got a couple things that we've got to get into place here. From this computer output, what we have is we have across this bottom row resting heart rate, the coefficient of resting heart rate, that would be the x-axis variable here. The constant is the y-intercept of our least square regression line. The resting heart rate is what they're using as the variable x in this particular case. So the coefficient of resting heart rate, or the slope of resting heart rate, so the slope of our sample data regression line is 1.786. So that is going to go in as our point estimate. And that's pretty obvious. 4 of the 5 options involve that as what you see before the plus or minus. So we are going with ruling out option A, right? Definitely not correct. Now, from here, we need to recognize that this computer output actually already gives us the standard error for our slope. It's this 0.453. There's no calculation necessary to do to get what goes into this final spot within our confidence interval build into place. We're putting 0.453 directly into that spot. Now, the thing that we're going to have to figure out on our own, the thing that we can't get from the computer output here, is we're going to have to figure out what our critical value is. Now, when you do inference for slope, you're always dealing with t-distributions as long as you know the sample size. We do know the sample size here. The sample size is 12. What we're going to do to establish our measure for degrees of freedom for our t-distribution is, for inference involving slope, always going to take that sample size and knock it down by 2. So we're dealing with a situation involving 10 degrees of freedom. We are asked to build a 95% confidence interval. So what we're going to need to do is we're going to need to identify how to go about determining that 2.228 is the value that goes here. So our answer is obviously option E, but if you're wondering where this 2.228 comes from one of two spots. If you have a calculator with inverse t capabilities, TI-84s would have that option, you can do an inverse t calculation to establish that t value. If you're relying on the tables at the back of the formula sheet, you want to go to the t-distribution table. The upper tail area is what's specified across this top row here. Now, if we're doing a 95% confidence interval, we would have the final 5% split evenly across the two tails, meaning our upper tail and our lower tail would have an area of 0.025. We have 10 degrees of freedom. If you look at that space within the table, there's where that 2.228 comes from. That's why we're going with option E.